Let us solve another numerical problem from refraction of light through a glass prism. Important for NEET and JEE Main. As you can look at the diagram, ABC is a glass prism. This angle is given as 60 degree. And a parallel beam of monochromatic light. Monochromatic means of single wavelength. Look, this is a parallel beam of light. I have considered a ray of it. It is incident on one face of an equilateral prism. This prism is an equilateral prism, means this angle is 60, this angle at B is also 60, at C is also 60. The angle of incidence being 55 degree. At this point to the side AB, this dotted line is the normal. So this is the angle of incidence in the rarer medium. Let it be mu1 is equal to 1, that is air. And the refractive index of the glass prism is mu2, let it be mu. And on this side also, it is mu1, that is equal to 1. The angle of emergence of the beam from the other face also given as 46 degree here. Then what is the angle of minimum deviation? Now, very simple, as you can look from the diagram, this ray at this point, this is the normal. This ray was supposed to travel along this dotted line, so it has bent by this much. Let it be delta 1. Again here, so this is the refracted ray. From here to here is the refracted ray. So from this ray is the refracted ray. So this is your angle of refraction R1. And at this point, this ray within the denser medium trying to go from denser to rarer, it was supposed to travel along this dotted line. So it has bent by this much, let it be delta 2, that is away from the normal. And it is given, this angle is 46 degree. We don't actually require all these things, delta 1, delta 2, R1, and this angle of incidence within it as R2. I just explained you so that you have a your lessons gets revised, right? So this is given as 55, this is given as 46 as angle of emergence, angle of incidence on this side, angle of emergence on this side, 46. And what I should remember you, during minimum deviation, this diagram is not for minimum deviation. During minimum deviation, this ray will be parallel to the base BC, and R1, R2 will be equal, and this I will be equal to the angle of emergence also. That is during minimum deviation. But we know this much, during minimum deviation, the refractive index of the prism is given by the expression sin A plus delta m by 2 over sin A by 2, where delta m is the minimum deviation. Now, mu is not given. The mu of this is not given, right? And for a prism, we also know A plus delta is always equal to I plus E, always. Where delta is the total deviation, means delta 1 here plus delta 2 here. Delta 1 plus delta 2 is delta. And how much will be delta 1? This total angle from here to here minus R1. And how much will be delta 2? Delta 2, this total angle minus this much, that is R2. So using that, we have derived in our theory classes A plus delta is I plus E always, where I is the angle of incidence on this side and E is the angle of emergence on the other side. So from this expression, delta is equal to A comes to this side. So I plus E minus A, I is given, E is given, A is given. So put the values, you get as 41 degree. So your deviation is 41 degree. We don't require all these things, delta 1, R1, R2, delta 2. But I explained so that your lessons gets revised. And we know, so this is the total deviation. Therefore, minimum deviation should be less than this. So delta m will be less than delta. So the answer is delta m in this problem where I is given, R is given and angle A is given, your delta minimum will be less than 41 degree. This is not a general case, it is a particular case. When this I is given, R is given and A is given, then how much will be delta M? You cannot exactly find out. It cannot be exactly found out, but it can be at least said that it is less than 41 degree. So let me, since there is some time left, let me revise here also. To this side is your angle of incidence, to this side is the delta. For different angles of incidence, if you plot a delta, you get a graph like this. Means as I increases, delta decreases, then increases. If you draw a horizontal line, means for this point, it is the same delta, but for this point, the angle of incidence is this. For this, the angle of incidence is this. This is I, this is E. When this I is equal to E, when this I is this much and E is this much, if E decreases, I increases, means at this point I is equal to E, and that point your delta is equal to delta M. Right, so that is all about. So thank you.